What's up guys, welcome back to the channel. Today in this video we'll be expanding the following expression that you see here to the fourth term using binomial theorem. So I've done videos on binomial theorem. If you already watched the videos, you can pause this video, try to solve this problem, and let's see if your answer is going to be the same as the one that you're going to get at the end of this video. Now, before I start though, I just like to say thank you very much guys for watching, subscribing to the channel, commenting, and don't forget to like and share the videos. Now, I'm doing this expression because there is one of the subscribers requested me to solve this problem. So I'm going to solve it, and I hope the subscriber will be able to watch this video. All right, guys, so let's expand this expression here. So before you expand this expression, you need to know the formula of the binomial theorem. Now, let me rewrite the formula underneath here. We know that we have a plus h, all this to the power of n. Now, you need to expand this using the formula. Pay attention here, guys. I use a instead of x because I don't want to have any confusion here. Right, so when we expand, obviously it's going to be a to the power of n plus, then the second term is going to be n multiplied by a to the power of n minus 1 multiplied by h, and the third term is going to be n multiplied by n minus 1 divided by 2 factorial multiplied by a to the power of n minus 2 multiplied by h. Now the last term, which is going to be n multiplied by n minus 1 multiplied by n minus 2 divided by 3 factorial a to the power of n minus 3 multiplied by h to the power of 3. Right. So in order for us to use this formula, we need to name a, h, and n based on our original formula. So we can say a is equaling to 4x, which is this part here, similar to that. Right. And then we can say h is equaling to 3 because this one here is 3. And as you can see, that is h. And then n, which is our exponent, it's 6. So from there, what you do here, you just substitute. So I'm just going to write the equation here and start substituting. Right, let's start. Remember, a is 4x. So wherever there is a, we put 4x there to the power of n, which is 6 in this case. Right, the first term we are done. Plus, now our second term, our n, it's our exponent there, which is going to be 6 multiplied by a, which is 4x to the power of n minus 1, which is 6 minus 1, multiplied by h. Our h in this case is going to be 3. There we go. Second term done. Let's go to the third term. Plus. Now, the third term we have n, which is 6, multiplied by 6 minus 1, which is n minus 1, by the way, divide by 2 factorial, multiplied by a, which is 4x to the power of n minus 2, which is 6 minus 2. Right. I forgot here, guys, our h is supposed to be squared there. Right. Multiplied by h squared, which is going to be 3 squared. There we go. Plus, let's continue. The last term, which is the fourth term, our n is going to be 6 multiplied by n minus 1, which is 6 minus 1, multiplied by n minus 2, which is 6 minus 2, divided by 3 factorial. There we go, 3 factorial. And then we have a to the power of n minus 3, which is 4x to the power of 6 minus 3. And then we have h to the power of 3, which is going to be 3 to the power of 3. So basically, this is how you do the binomial theorem. Okay, now the next step, we simplify each and every term further. Right, so we have the first term, which is 4x to the power of 6. So if you put that on your calculator, you will have 4 0.096x to the power of 6. This is our first term. Now our second term, we say plus, we have 6 multiplied by 4x to the power of 6 minus 1 multiplied by 3. This is going to give us 18432x to the power of 5. All right, so this is our second term. Now our third term is going to be 6 multiplied by 6 minus 1 divided by 2 factorial multiplied by 4x to the power of 6 minus 2 multiplied by 3 to the power of 2. So this also, the third term, is going to be positive. Remember guys, when you do this, do not forget that this 4x is the a. And remember, the a is the one that is affected by the exponent there, meaning the 4 also going to be affected by the exponent as well. So let's do it. So the answer here is going to be 34560 x to the power of 4. There we go. This is our third term. Now our last term, we have the following here. We have 6 multiplied by 6 minus 1 multiplied by 6 minus 2 divided by 3 factorial multiplied by 4x to the power of 6 minus 3 multiplied by 3 to the power of 3. Now this one also is going to give us 34560 x to the power of 3. Guys, this is how you do this one here. It wasn't really that difficult. All you need to know is how to use your binomial theorem, guys. Okay, so these terms here, there are 4 terms: 1, 2, 3, and 4. This is what they wanted you to expand the expression there. All right, so guys, I hope you understand this. If you didn't understand, there is a video that I will leave on the description, and the very same video will pop up on the top right of the video that you're watching at the moment. That video explains how we actually expand using the binomial theorem. And also I'm going to leave another video where I explain exactly how to use your calculator when you are expanding them. And I hope you manage to see the trick here, that a is actually the whole thing is 4x, and then h is 3, and n is 6. Because if you can notice that, you can realize that this 4 is affected by the exponent there. People tend to exclude this 4 and only allow the exponent to affect x only. But in this case, the 4 also get affected by the exponent. I hope you guys managed to understand. If you didn't understand, you can leave a comment in the comment section. And also, you can rewatch the video where you got lost, guys. Thank you very much, guys, for watching. Do not forget to subscribe to the channel for more videos. Till next time, cheers.